Our next presenter, second to last, is Tim Estes, and he has used his academic training in the philosophy of language, mathematical logic, and semiotics in a unique way. He and his team at Digital Reasoning have developed a technology that can interpret large amounts of unstructured data, and their product has been battle-tested by several government agencies. Tim?
Thank you, Maria. Thank you. So, I guess I feel like I get a clicker, don't I, for someone? Who's got it? Who's got it? Thank you. Well, thank you, everybody, for coming. This is an amazing turnout, and thanks to Maria for just a fabulous program that exceeded all possible expectations. It has been a real privilege to get a chance to get engaged in New York, to get a chance to spend time with leaders in these various institutions. And the most unexpected privilege has been to be with these amazing entrepreneurs. You've heard 4 of them so far. There's one more. And they're building some amazing companies, aren't they? And I think that is a level of fun and interest to kind of be in the trenches and build that camaraderie. So I wanted to give a little bit of a shout out to some great work here. So a little bit of background on us. In some ways, we're unique to the program this year because I think we would have been too big last year. A lot of the participants last year are much more early stage. Some early stage this year, some are a little more mature. And we're probably the biggest one here. We've been around 12 years, so you could argue one of the world's oldest startups. You probably haven't heard of us because we are working mostly in the defense and intelligence community, and we will not do much citing our customers here. But needless to say, those and many people in the banks have a good idea of how deep we go there with some people. And we have some external validation of that. The CIA's venture capital arm, InQtel, did an investment in us a couple of years ago. They've been an absolutely tremendous partner. And then last year, as we were starting to look at how we take our technology from the intelligence space into the broader market, we got the interest of Silver Lake, and Silver Lake invested in us, and that's allowed us to accelerate our movement into this market, the financial market, along really 2 major applications, the sort of financial intelligence applications. How do we make sense of unstructured human language data that's out on the web to try to drive revenue? And then the risk mitigation applications. How do you use it to find problematic things behind your firewall? And clearly our history, what's kind of different about us is there's a lot of people playing in the web space, creating analytics on web data, social media, sentiment mining, that type of thing. What's interesting is all our expertise has been on data that no one will give to anybody else. And we think there's a good mirror to the banks in that. There's a lot of data where your data is your value, and it's not going to live on Google. It's not going to live in those areas. I've heard it over and over again from the leading CIO level people like in this community that they need a solution that runs on their clouds. And we think we're a pretty good option for that. So we are essentially a platform. So we don't actually bring a lot to demo without great companies like Centrifuge. We're integrated in another place, and we're looking to integrate maybe with a couple of the other parties here. And so we are not a visualization company. We are building out a complete experience with partners and with our own development customized efforts. But most of those visualizations truly become powerful when you make sense of information, because it's ultimately structured data that machines understand. And if the data starts off as unstructured, you can't do anything without a human reading it. And something has to automate that step, and that's why we exist. I founded the company 12 years ago, out of college, 3rd year. And that's actually how a philosophy major ends up running a company like this. You have to found it. It's the only way. So from my background, really our story is in 2 or 3 steps. The first was starting something as a way to think of how you network college students together. They had this idea of a social network in 2000. It was such a bad idea. So that's actually the roots of the company. Was mining conversations for social networks was a thesis or an idea at UVA, and we had started that up. And then we found out really right before 9/11, a group in the Army came and said, we have a overwhelming data problem. How can you help us with this? How can you visualize information? And we said, visualization is great, but you can't visualize what doesn't make sense to a machine. So you have to process it with various advanced algorithms to turn it into something visualizations can understand. And that basically became like the beginning, of our piece. And then post 9/11, it became a very big issue, obviously, right? That's been the other privilege of being in New York, has been to be that close to it. So a lot of the people that work here, that's why we do it. So since that time, what we've seen is it took about 7 years of work on those algorithms to get them to work and work at scale. This is a very hard problem. There's going to be a lot of big data startups in this space, and people that think they can spin out a university and have an answer to this in 6 months don't really know the problem that well, frankly. It's a very hard problem. Billions of dollars have been spent in the Intel community trying to solve it. Billions are being spent elsewhere. And we think we're part of the culmination of that. So what's happened is FinTech has given us an opportunity to get a very deep inside audience of where would you apply that? And we had ideas about it, but we needed a lot of feedback and validation, and we'll talk about some of those things today. So once again, thanks to the program and the people that have pulled this together, and thanks to New York for actually having the proactive vision to try to do this, to sort of accelerate that for companies that didn't start here. We're out of Tennessee. So we were the first thing In-Q-Tel ever invested in Tennessee. But it's been beautiful being in New York, and look forward to sticking around for quite a while. So everybody here who's done a big data thing has seen the hockey stick chart. Okay, so people that know big data have seen the data exploding on the other side of the chart. The thing I want to focus on here is the left side, human attention. It's not going anywhere, right? So our problem is not just the data is exploding. The problem is that the data that's exploding is unfortunately a lot of things computers don't understand, which is unstructured data. And a lot of tools are very valuable. You've seen 2 or 3 today about how if you have that data structured, you can take on that 20% or so of data and make it much, much easier to take finite human attention and leverage it. That's the great purpose of visualization. But if we leave out the 61% there that's coming, that we already have long since surpassed the human time to deal with, well, we end up with this problem, right? We end up with a huge gap in understanding, which has very expensive consequences. And in the Intel space, it's a consequence of life and death. In the banking area, what just happened there? In the banking area, what we find is that reputation in an environment where things are so connected is very, very valuable. That one errant email, and that's what I'm going to talk about next, one errant email, getting in the New York Times, there's a lot of press here today, can drive a lot of a stock price for a little while, and that's a multi-billion-dollar problem. And just like in the 9/11 or post-9/11 world, you only had to be wrong once to have a bad thing happen. So it takes not a sufficient answer, but a comprehensive answer. So search can't get you there. That's part of the thing we have learned. And looking specifically on email, and learning from various institutions, we're finding out that you're dealing with millions of emails per day, terabytes a year of email, and that's a lot. To give you an example, all of English Wikipedia is less than 10 gigabytes of ASCII text. So the banks internally, in just email alone, are producing hundreds and hundreds and hundreds of Wikipedias in English every year to be connected. And somehow the banks are now having the responsibility, and this is true of everyone, that we're supposed to know everything in there so no one's doing anything bad. And we're supposed to do it without hiring 100 million more people. Right? So the regulation, the public consequences, and then finally the massive value that's tied up in there of which customers do you know well in your enterprise, who are people that aren't your customers that are tied to them, that the relationships are sitting there in your email. Those things right now are limited by that human attention line that's not getting any bigger. So fundamentally, we wanted to say, well, what are we doing now? We came in, we didn't quite know what the banks were doing today. We had guesses about it. We knew what the Intel community was doing today. We didn't know what the banks were doing. And I'd say that's been a great privilege in working with the banks, as we have gotten deep, deep insight that wouldn't have been possible without the access of the program to know the internal IT readiness for unstructured data. And what we found is the very best in the world at this, and the banks IT-wise are at parity with many of the people in the community. So it is the very best in the world. Still have a process that essentially is just adding data onto documents and using search to come up with answers. So there has not been an automation to go from documents to entities. Every question today that is a risk-oriented question is not so much about what the document was. It's what did they say, to whom did they say it, was it pejorative, was it a compliment and therefore this person might be interested in this product we have. So that information is the facts that lie within a document. And moving from documents to entities is not been automated yet. So I think that as we look at what we did in the intelligence community, we found out that the same transition needed to happen in the enterprise, to move from a search, rank, and read process to a read, resolve, and reason process. And I'll explain what that means in a minute, where the work is not done based on search and being able to look at the best results and then take a sampling of it and then say, this is what's happened. You can't do that when you have hundreds of Wikipedias being created every year in a group that only has 10,000 people or even 300,000 people. It takes something very, very different. So we, in partnership with one of the banks, are building out an application to leverage our technology on email. And we'll use it to be able to make emails searchable and relatable based on facts and relationships in them at completely bank-level scale. And at that level with facts and relationships, it will be the first thing of its kind to knit all together at that scale. So I said I'd explain read, rank, or read, resolve, and reason. What we found as we went through a decade of work in this space in the intelligence community is that you cannot get there with any one magical algorithm. The process has been an assembly of technologies, and in many cases in the government world, people have bought many different commercial technologies or have had contractors build many different specialized government implementations and glued them together. As a result, it hasn't really ended up working very effectively at scale, and it's also led to a lot of repeated updates and maintenance of that, making it not adaptable to new domains. So when we looked at this problem, we said you have to take the documents in the original form, and you have to pick technologies to read those documents that are based not on mapping and rules and customizations, but on training, on learning. So the fundamental differentiation of digital reasoning is we leverage machine learning at every stage of our system. That's how you can multiply and augment human attention. It's how you can automate understanding ultimately, is if you can teach the machine instead of program the machine. So we break up every document into its entities and relationships, whether we know what the category of it is or not. So we don't have an ontology in advance for those that know what that is. We don't have to have a model a priori. It will knit together everything that's said. And it will aggregate those globally. And then we do things that whole other companies do just for this one thing, which is resolve those entities across all the data. You're going to be looking at people that are referred to one way in one email and one way in another email very differently. And if you cannot link those together, you'll miss potentially the critical inference. And that's an analytic process that happens well before you leverage a great tool on it. So that enables the real thing we're trying to replicate, which is the human reasoning process. What is an important pattern that we're trying to discover, such as this person here is very similar to this other person and they're not a customer. Let's go talk to them. Or this, this phrase here that dealt with something really pejorative like Muppets or something is not a rule where we want to think of every pejorative term and put into a rule base. Instead, what we want is we want to give examples and the system catch it beforehand. And you can figure out fairly straightforward why that would be so similar to the intelligence community, right? We cannot stay ahead with guessing every pattern with human beings. We have to give it examples, and it has to generalize, it has to learn. So we believe the only answer to this problem, really, is to put a layer between the big data infrastructure, where there's been a ton of investment, and the application space. And we think this has been a very big missing layer. That layer right now is a lot of services, a massive amount of customization of services, of multi-billion-dollar businesses that manage that for every siloed application above the orange box. And we believe that is unsustainable in an environment where hundreds of English Wikipedias are being created every single year. So we fit there. We fit over the big data landscape, and we have proven it in the community that we're in. And we're now bringing it out to a variety of applications, the primary one being into the financial area, but we also see things in e-discovery and legal. Wherever you have a lot of human reading, bottlenecking, relationship discovery, reasoning, and inference, there is a role for this. And so we've actually hoped, if I had my druthers about it, you can't always pick your markets because of the way markets are structured, but we thought when we went into the defense and intelligence area that national security was the greatest moral use of this technology. We think the second one is in healthcare. We kind of have to wait for the healthcare market to get ready for it, And so we're still trying to weigh that out, but we believe that the discoveries, the cures that can be done from all the doctor's notes will change the world. In the meantime, we think that the banks that we've dealt with are overwhelmed with these problems at different levels, and we think that there's a lot of economic security and moral cause there that can be helped with this. We clearly are already working in the kind of the intelligence space. We're starting to apply it online. We announced a partnership with Connotate Fetch to do retrieval of data from online and analyze it, so you can basically subscribe real time to websites and get graphs of relationships from human comments. And then finally, we think there's immense things to be done in intellectual property. And we built a demo where we ingested the entire patent office since 1976 earlier this year, connected every technology and every inventor, and could actually tell you which inventors were similar, not based on the words in their patents, but based on the nature of the technologies described in the patents. And that's for every patent that's still active today. We did it in 30 days, and we ingest the data in a matter of days. So getting to like a conclusion here, and then handing it off, we believe that this automated understanding layer will revolutionize every application in the enterprise because it will make usable data that's unstructured now that only is currently available if humans are in the loop. And just like essentially telemetry and automation allowed us to fundamentally change air travel, where most of the decisions a pilot is making are not really atomic decisions. They're decisions that a software is making on the plane, and the things that they're changing are amplified 100-fold. We think that automation over the data that's been created in this big data explosion, that is human data, is similarly revolutionary in all kinds of ways. And we've seen it in the Intel space. We were a profitable company before Silver Lake invested in us. We're growing out rapidly now, and we look forward to the projects that are underway in the banks. So thank you very much for your time, and thank you for the program.